In this video, we will define linear equations and talk about graphing them. So first, let's look at the definition. A linear equation is one that can be written as y equals mx plus b. It does not mean that a linear equation is always in that form, but it can be rearranged into that form, y equals mx plus b. The graph of a linear equation is a line with slope m passing through the y-intercept 0, b. So when you write a linear equation in this form, y equals mx plus b, this is sometimes called slope-intercept form because it gives you the slope of the line, that's the first coefficient, m here, and it also gives you a point on the line, the y-intercept. I want to say just a little bit about slope. Slope is the rate of change of one variable in respect to the other. If you're looking at a graph, we can think of it as rise over run. It's the vertical change over the horizontal change. So for example, a slope of 2 can be interpreted as 2 over 1, which means that this graph moves 2 units up for every 1 unit in the positive x direction, which is to the right. That's how I would interpret slope as we look at an equation. Let's look at some examples of linear equations. First, we have the equation y equals negative x minus 3. This is in the y equals mx plus b form. The slope is this first coefficient, which I would interpret as negative 1. Remember, slope is rise over run, so I might think of that as negative 1 over 1. The y-intercept, the y value is given by this last number, so the y-intercept is a point at 0, negative 3. That is where the graph of this line crosses the y-axis. So if I want to graph this equation, I can graph it straight from this information using the slope and the y-intercept. Here is a point on the line, so I can start here. Let's draw an XY grid. I can begin at the point 0, negative 3, that's right here, and then I can follow the instructions of the slope to graph another point or two on this graph. We're starting at 0, negative 3. We know the line passes through that point. We follow the instructions of the slope. The slope is negative 1, so negative 1 over 1 means down 1, right 1. Down 1, right 1, and that gives us another point right here at 1, negative 4. I could keep following that pattern to get a couple of more points and then connect them with a straight line. Here is the graph of the line y equals negative x minus 3. Another example, 4x plus 3y equals 12. This is not in slope-intercept form, but we can rearrange it to put it in that form. Let's see how that looks. We want the form y equals mx plus b, right? So let's subtract the 4x. And I'm going to write 3y equals negative 4x plus 12. And then let's divide by 3. Make sure you divide everything by 3 here on the right side. We get this equation. Y equals negative 4/3 x plus 12 over 3. 12 over 3 is 4. So y equals negative 4/3 x plus 4. I just rewrote this equation in slope-intercept form. The slope is negative 4/3. The y-intercept is 0, 4. So let's graph this example. We're going to start at the y-intercept, which is at 0, 4. That's right here on the y-axis, and we're going to follow the instructions for the slope to find another point on this line. Negative 4 over 3, that means down 4, right 3. So I count down 4 units, right 3 units. That gets me here to this point, 3, 0, and I can connect these two with a straight line. This method of graphing a linear equation is called using the slope and the y-intercept to graph. So I'm rewriting the equation in slope-intercept form, and I'm using this information about the slope and the y-intercept That's not the only way to graph a line, but it is one good way to graph a line. Let's close this video by looking at two examples that are not linear equations. So these are non-examples. Y equals x squared minus 1. Here there's a power of 2. This is a quadratic equation. We'll cover those later in the semester. Second, y equals x plus 3 over x minus 2. This is considered a rational equation. There's a numerator and a denominator expression, and we'll cover these later in the semester as well. So I'm just presenting them now because they are not linear equations. Linear equations all look like this form: y equals mx plus